what I'm going to do for the next half hour or so is do some Pygame development, and I'll start by introducing the software I'm using. So this is PyCharm Community Edition. Now PyCharm is an IDE, and it's by JetBrains, which is a company that makes IDEs. The advantage of using an IDE is manifold. So you end up with a interface that includes, like, for example, syntax highlighting, and also it inspects your code. So if there are problems in your code, it will tell you them while you're writing the code itself. So this is just an arbitrary file, pygameui.py. So let's close all these files, and I will go over just a quick outline of what has been done recently, and that will help hopefully us figure out what we should work on right now. So let's run the program as is. So the way to run the program is just to run main.py, and that would be the Pygame UI. And we see that we have a maze game dev up here, a menu. The menu isn't done yet, but this will be where the menu is in the future, and it's displaying a maze down in this box. Now the first thing I see is that the box is taller than my screen is tall. So I don't think I have a particularly small screen. I feel that maybe it would be a good idea to shrink the screen a bit. So that should be our first order of business. So that would be part of the Pygame UI. So I'll open UI, pygameui.py, and we'll find where it's setting the window size, right? So let's go to the initial. Okay, so looks like width and height are actually set by the constructor, which means that wherever the Pygame UI is created is setting the width and the height, and that should be in main.py. So let's find where that's created. Game equals game, so we are creating a game, and if we are using the Pygame UI, which we are making a window with height 800. So the first thing I can think of is maybe we should set this height to maybe half that amount, to 400, and we'll see if that. Okay, so now it's fitting on my screen, but the maze looks a bit off. So maybe we can change this to something like 600. Let's try that out. Oh, whoops, that's the wrong place. Maybe we can change this to 600. Alright, so this maze still looks somewhat squished, and I'm not sure if there's a good way to fix that, because the menu takes up space, and we don't want the maze too thin. So maybe it would have been a better idea to put the menu on the side instead of up here, but I think we have room for like maybe 100 more pixels. So let's squeeze out as much space as we can, and then maybe if we wanted to move the menu, we can do that in the future. Alright, so I think this is as many pixels as we can squeeze out, and that maze, I don't think it looks too bad. It is a bit squished, but that just means it's rectangular. Okay, so that would be our first change, would be to increase or to decrease the height of the window so that we can see it all. Alright, so let's go back to the program itself. What it looks like right now, to me at least, is that we have a maze printed out, but there's no gameplay yet. And I have a feeling that we haven't actually implemented the code needed to make the player. So maybe that would be a good goal for the next half hour or so, is to get a player working. Now, one difficulty is that to draw the player, we actually need graphics for the player. Now, I do think that someone has made graphics. Let me see if. Okay, so this is okay, let's call this the player. I don't think this is supposed to be a player, but I don't think we have any other graphics, and to be honest, I'm not very good at drawing graphics, especially like on the spot here. So let's use heart1.gif as our player just for now, okay? And okay, so just a quick review of how the code is working so far. Self.state. So basically the UI is a class, and a class is a collection of variables, and those variables are related in their functionality. Now self.state that is the game state. That's how what the game is like right now. And when we draw with the Pygame UI, what we're doing is we're calling this draw, and then we generate our title, info, menu, and the game area. So the method we're looking at is actually gen game area. That's where we draw the maze itself, and it's also where we're going to draw the player. So we're going to quickly look at GameState.py, which is a file where we store the GameState class. And this is another class, and this is the class that stores the player. See self.player right here. So since we're only going to draw the player right now, let's just say, okay, so this is, remember, we have a game state, and that would be the self.state here is a game state. And you can even see that it says equals game state self.maze, right? So let's go to our Pygame UI. So what we want to do is we want to draw a picture, and that picture, the location we want to draw it is wherever we draw, wherever the player is. So let's first calculate the player's location. Okay, so call this player location, and that would be self.state, which is the game state that we're using, .player, because self.player here you see is the player itself. And if we look at the definition of player, how do we get the location of the player? Well, it's actually, a player is a subclass of entity, and what that means is that all of the variables that entity has, player also has. So to get the location of the player, all we have to do is .player. So sorry, this is the wrong file. .player .location, and in fact it's even filling that out for us, and that's one of the benefits of an IDE. You can complete your code really quickly. So if you didn't see what I did there, I just pressed enter, and the whole thing just filled in for me. So that saves some typing. Now that we know the player location, what we can do is we can draw a player at that location. So let's go here, and the way we draw in Pygame is game area, which is the canvas that we're drawing in a way, .blit. And what we blit is the picture first. So what picture are we going to use? Well, basically the way we're loading our resources, they're all loaded in this method, load resources. So we're going to load a resource for a player, and we already said that the image we're going to load is UI/heart1.gif. Okay, so that's the resource we're going to load for a player. And just like we've done here, we're going to have to scale it so it can fit in the right location. So we're going to do pygame.transform.scale, and then our player, so the resource we're using is self.resources, and then player. So you can see the benefit of an IDE here is I'm saving myself a lot of typing. Now the other part of scale is how wide we're scaling it, and in this case I think it's reasonable to scale it to the tile sizes. The players should be big. It shouldn't be half a tile, it should just be the whole tile. And finally, we need to draw it to the right location. So that means we have to draw it to a rectangle. And we can even just copy the code here, the tile for the player. So we'll call this player tile. And that is a rectangle. So rect is Pygame's rectangle here. So we give it the x coordinate, but instead of x, we're actually using player lock 0. Now player lock is a tuple, so it's like an array. So player lock looks something like this, x, y. So to get the first element, we have to use player lock 0. And to get the second element, we have to use player lock 1. And then we'll use the tile size in pixels, tile size x, tile size y. That will be the width and the height of the rectangle. So now that that's dealt with, we will put player tile here, and if everything goes right, it should be drawing our player. And as you can see, our player has now been drawn. So we can cheer. Now, so that's the first part to actually get the player drawn. Now, none of our controls are working, right? So we haven't implemented any way of actually moving the player. And that's going to be slightly more complicated to implement, so we'll focus on that right now. So now that the player can be drawn, we need to first do the backend. How is our server? How is our game state gonna handle a player movement. And I'm actually not too familiar with this part of the code, but I think Ethan was the one who was working on this. And what Ethan intended was that we have what we call events, and events are kind of classes that basically have their actions, right? So one type of event is called user input. So I guess that means when we press an arrow, we send an user input event to the game state, and one of those actions is move. So when we make an event, really what we're doing is we're saying we'll give it an action, and we give it some kind of argument. So I'm guessing for move, we might say X shift, -1, Y shift, +1. Or maybe we would say something like move type is north. So actually, I quite like the second idea, just because it helps separate the meaning of the code, like so north is the meaning. We mean to move north, from the actual like code itself. We don't want to have to think about numbers, -1, +1. So what we do instead is we'll have all of these be displacements. Now if we actually move north, that means we're not displacing ourselves in the X direction, and we're moving 1 up in the Y direction. And then south would be very similar. It would be 0 +1. So we have north and south. Now east and west. East, we're now moving 1 left on X position, and east is 1 right on X position and none in the Y, and west would be 1 left and none on the Y. So just these are constants, right? These will never change, which is why I'm using capital letters. So when we move, when we make our event to move, what we would do, so I'm just going to put this in comments just to show you, we would do something like this. We would say event equals user input, so we're creating a new class that looks like that, and what we give it is the action, so our action is move, and what we're going to use is the direction of movement, so let's call north, okay? So that would be our format for sending events. So before we get any of that done, we actually have to be able to handle this event. So right here we have handle input, self input, and we are not actually handling move right now. If input action is move, we just pass, and pass means do nothing. So we gotta fix that, right? We actually have to handle the player. Oh, now we also forgot one thing. We also have to take into account okay, so actually this will be direction equals north. We actually have to take into account what we're moving, right? So we can say the entity we're moving is something like I don't know, like we could say the entity we're moving would be the player. I don't know what's a good way to reference that right now, but this is just a demonstration. In practice, it wouldn't be that complicated. So now we're saying what we're moving and what direction we're moving in. So when we parse this, what we have to do is we have to basically check two things. One, we have to check, so let's just quickly write our steps here. One, check if the entity can move to the destination. So that means not all squares are passable, remember. Some squares are not passable. Like the square is not passable if the maze is 0 at that point, right? So we have to first check if the move is allowed, which is that's step 1. And step 2, we need to actually move the entity. So now that we have the pseudocode in a way done, let's first get our definition. So what entity are we moving? Well, to get that, we have to look at input. And when we stored the arguments, it's actually in an argument. It's a property called .args. So input.args would be the argument we're using. And what we want is entity. That's what we're moving. So that's the argument. Entity is what we're moving. And direction, what we would say is input.args direction. Now we check if the entity can move to a destination. So what we can do is we can first calculate the destination. Destination would be the entity.location, right? And then we have to add in the direction, right? So actually, remember, destination is a tuple of x, y. It looks like x comma y. So what we have here is the location x, entity.location 0, plus the direction x, direction 0, because both of these are of the form x comma y, and this is also x comma y. So what we can do here is entity.location 1 plus direction 1. And then when we close that, okay, so when we close that, we've now calculated our destination square. Now we can check if the entity can actually move to destination. So what we can do is we will say if destination, or if, so first we need to find our maze. What is our maze? Looks like our maze is self.maze, is that first generator, 1616. So basically we're checking our maze, and the way mazes work, we just give it a tuple, right? So we'll just ask, is the destination free? And basically, if it's 1, that means it's free. If it's 0, it means it's not free. So if it's free, it's going to go into this if statement, and otherwise it's going to go into this else statement. So I'm thinking that, you know, if it's not free, we shouldn't like throw an error or something just because the user's trying to go somewhere he can't. We should just not move it. So what return means is we just leave the function, right? We don't do anything. Now, if it is free, on the other hand, we'll do what we wanted to do in the first place. So just we're going to rearrange our code here. And in fact, we don't even need the else statement because the function will automatically return. We'll just move, all we need to do is move our code here. Okay, so we're going to move the entity now. So basically, that I think is pretty simple. We just set entity.location to the destination. So now the entity should have moved. Okay, so before we get ahead of ourselves and actually do the input part, let's try to get it to handle that input. So what we're going to see self.ui.poll. That's the way we get inputs. So let's go to Pygame UI and the poll part to get inputs. What we're going to do is we're going to just pretend the user is constantly trying to move the creature down. So move would be that. The player, we can get the player by going self.state.player, and that would be our entity that we're moving. And direction, let's say we always move we also need to import north. Let's say we, how about south? Let's say we always move south for now, alright? And this is, remember, just, so here, we also need to make sure that this doesn't, like, constantly move it too fast, so we won't be able to see it. So here's an idea. We'll say, like, 1/10 of the time. So if my random number is below 0.1, okay, so 1/10 of the time, random.random returns the number between 0 and 1. 1/10 of the time, we'll tell the player to move south, and we'll see if it actually works. Okay, so clearly on this maze it's not going to work. The player can't move south. Oh, and on this maze, maybe the frame rate was too low, so you didn't see it. But our player actually had moved south, and you can saw that again there. Nope, you cannot move here. Yeah, you see the player is actually now moving south. I'm gonna slow this down just so you can see it clearly. See, the player is actually moving south, and this is not because of our input or anything. This is because of fake input. Let's try to. Yeah, unfortunately, sometimes the mazes are very clogged. Here, we'll have it move south, and then we'll also have it move east, just so we can see movement for a bit longer, right? Oh, and we also need to import east. So the nice thing about IDE is you can actually just import it on the spot. So what I did there was I clicked Alt Enter, and then the first thing that showed up is import east from events. So that works perfectly. Okay, so now it's going east and south. So you can see it actually moves east and south. And if we wanted to like move it in all 4 directions, that would be actually that would not be that would look bad. Okay, so here there's a maze that it can actually move a wall on. So you can see it actually moved. So that part of it is working, which is good. Now we can now focus on not faking the input and actually getting real input. Okay, so this part of it, is Pygame work. So the way it works is all events in Pygame, like including keyboard presses, are called pygame.event.get. So what we can do is we can say if event. Actually, my Pygame is quite rust. We're going to look at event documentation. So how we get keyboard input in particular. So we've already gotten our events. What we want to do is we want to look at the event type. And the event we're looking at is key down. That's the event we want. Because when you press a key, the key down event shows up. So we already have if event.type is quit. So now we need to make a new type. If event.type is equal to key down. And then what we can do, instead of just quitting Pygame, we need to yield an event. So in this case, we actually need to yield different events depending on what key is down. So I believe it is event.key. Actually, so I believe this is true from the last time I've checked Pygame. So let's try it out, okay? So if we press, I'm going to use WASD. If we press the W key, we want to move the player left. So user input and move entity is the player. So that would be self.state.player. And direction would be, and west is left. So we'll have to import that. Oh, actually, W. If you're using WASD, W is actually north. Sorry, W does not mean west. A is the one that we want to be west. So if event.key is equal to A, and I'm not sure if this is going to work at the moment because I'm not sure if event.key is the right symbol, but we'll figure it out as we go. We'll do direction is west. We just need to import that. And you know what? This is all just copy paste. So I'm just going to copy paste this twice. That would be for S. And that would be for D. Now, generally speaking, it's not that great to copy and paste. I should actually write a function to do this, but since it's just one line, it's not a huge deal. Alright, so if my memory is correct, this should allow us to press WSD to move, and it does not. So my memory is not correct. That means it could be event.unicode that I'm looking for, and not event.key. So I will check the Pygame reference afterwards. I'm just running a bit low on time right now. So let's hope that, yes, it looks like it's working. So you can't see my keyboard presses. What I'm doing right now is I'm pressing D and S to go down, and A to go left, and S to go down, and D. And actually, I'm able to navigate the maze. So that was actually the goal. And you can see I'm not allowed to hit walls. If I try to hit a wall, it won't let me. So that was actually the goal of our whole endeavor here, was to be able to actually navigate the maze. And it seems to me that we've succeeded in that goal. So I feel that that's enough for code changes, for now at least. So just a quick recap of what we did. So first what we did is we slightly decreased the size of the window. It did make it a bit squished, but that was necessary because it didn't fit on my window otherwise. The next step that we did, the next step we did was we added a few tuples here to describe how movement works. Then what we did, we went to our gamestate.py, sorry, not gamestate.py, our game.py, which should be in main, and we changed handle input to be able to move the player. Remember, this does work for enemies too, just we can't see the enemies right now, based on the events that we get. And finally, we added code to Pygame UI so that when the user presses the W, A, S, or D keys, it actually sends the appropriate events. So none of those, and we can get rid of the testing code that we use. Now that those are done, I'm going to just quickly show you another benefit in IDE, is that it lets you commit changes really, really nicely. So basically it just showed me all the changes I made, and I just type a commit message. For example, I might type added display of player and movement of player to Pygame UI, and that's a good commit message. I click commit, and it would have committed it. Now I haven't pushed it yet, but that's just I believe that even has a push button here. But I can always open Tortoise to do that. So I believe that's it for this live stream. If you guys found it interesting, just leave me some feedback in the Facebook group, and I will see if I have time to do more live streams. And I think we did get one step closer to our goal, which was to make Pymaze in time for June 3rd. So I'm gonna shut down the live stream now. I hope you guys enjoyed, and yeah, maybe see you later.